So now what we're left with is that the expected return on the portfolio is basically the risk-free plus the sigma of the portfolio. Now I can put this here divided by sigma A, or I can put it right over here because the two are multiplied with one another, right? So this is multiplied by expected return A minus the risk-free, and we divide this by sigma A. Okay. Now this is a linear equation. Okay, a linear equation. There is no square in the equation. Okay. So we call that a linear equation. Now, if you recall from your mathematics, in order to make this, hopefully to make this more easy, if you remember in your math classes, we used to take that y equals a plus b multiplied by x. Okay, this is a linear equation. Okay, this is a linear equation, and what we used to say is that if y is the dependent variable, okay, then a is the intercept, okay, b is the slope, and x is the independent variable, okay, and x is the independent variable. Now, this is the tricky part here. The tricky part is, now this is the risk-free, which is the intercept, okay? No tricky business here. But the tricky business is right over here, because the slope, you might think, well, b is the slope, so sigma p is the slope. Well, no, sigma p is the independent variable, okay? Because the expected return is dependent upon the risk of the portfolio, of this new portfolio. So this is the independent variable, and this is the slope of this linear equation, okay? Now, this formula we need to commit to memory. We do not need to know this derivation, although it might help you with understanding this, the whole idea behind this, these formulas. But for sure, you want to memorize this final formula, because this is called the capital allocation line, and it is highly testable. Okay, guys, it is highly testable. They like it so much. They might ask you, what is the slope of this capital allocation line? So you need to memorize this formula, and not only memorize it, but also understand what is who is the independent variable, who's the slope, who's the intercept term, okay? And what is the intercept term basically says. Now here, the intercept term, which is the risk-free, it says basically if you take zero risk, meaning if this whole expression is zero, then you would be expected to earn the risk-free rate. Okay, this is the intercept. The intercept, as we're going to see on the next slide, is basically what intersects on the y-axis. Okay, again, you need to memorize this formula, capital allocation line, very important, very testable. Now, this capital allocation line is different for different investors, because this risky portfolio, this optimal risky portfolio, is based on expectations, right? It is based on beliefs about how would those securities in this risky portfolio would perform in the future. So it is basically expectations, and they are different for each and every individual in the market. Now, let's introduce the idea right away. And only if, and this is impossible of course, if all investors in the market have the same expectations, they have homogeneous, they call it homogeneous expectations with regard to the asset's future risk and return, meaning that they all have the same optimal risky portfolio, then we call this optimal risky portfolio the market optimal risky portfolio. Okay, we call it the market optimal risky portfolio, and we do the same steps. Okay, in order to derive the linear equation that combines the market optimal risky portfolio with a risk-free asset, we do the exact same steps. And so here, for example, instead of expected return on A, which is the expected return on the risky portfolio for a specific individual, now it is for the market, right? Now it is for the market. So here we substitute, okay? And if you carry on and do these calculations, what you get finally is here you get expected return on the market instead of expected return A minus risk-free divided by sigma m, okay, divided by sigma m. And here what basically changes is that instead of expected return for this specific individual, for this specific individual's optimal risky portfolio, what he thinks or she thinks is optimal in terms of risky assets in the market, now it is unified for all investors. So here you've got the market Sharpe ratio. We call it the market price of risk. But more on this later. I just want you to understand these derivations, go by them step by step. They're not easy to gauge at the first time you see the video or you read them, but try your best to know these calculations, or at least the very minimum is to memorize both the capital allocation line formula and the capital market line formula, the CML, okay, the CML. Both of them are highly testable. Both of them have the same way in deriving this linear equation, okay? They only differ here in these expressions, all right? And these expressions. So, if we now move to the graph, okay? Now remember, we have arrived, now we're talking about capital allocation line, okay? Capital allocation line. Why? Because I don't see here any M sign, okay? No M's. This is I, okay? I, which is the expected return on the risky portfolio, not on the optimal market risky portfolio. No, on the optimal risky portfolio and the specific investor's belief, and here on the standard deviation of that optimal risky portfolio, if in terms of a specific investor's beliefs. Okay, so now the investment opportunity set, or putting it more simply, the investment opportunities for a given investor, where they're infinite, right? They're infinite. Some of them are inefficient, right? Some of them are